In this video, I'll be going over a couple of examples for how we can multiply matrices. So here you can see just a brief description of the process. So the element in the nth row and the nth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column N of matrix B. So this is really how it works. Now, back up here for just a second. First thing you do need to check is if you're even able to multiply the matrices together. So to do that, we look at their dimensions. So here A is a 2 by 2, 2 columns, or sorry, 2 rows, 2 columns, and B is also a 2 by 2. And since I'll be taking A times B, we look at the inside numbers. So long as these inside numbers are the same, you are allowed to multiply, and the new matrix will have the dimensions of the outside. So in other words, it has this number of rows for the first and the number of columns from the second. Now here's sort of the difficult part. It's tracking how you might go by or go through finding the individual elements. So if the answer is a 2 by 2, then it has 4 elements that will go into the matrix. So if I wanted to find, let's say, the number that's going to go in this spot, what I need to think about is this is technically the element that would be in the first row and the first column. So what we do is we take the first row from A times the first column of B. So that's why you see here it's A times E plus B times G. If I needed to find this spot, so this is the first row, second column. So I'll look at here in yellow, the first row, so that's A and B again, and the second column, which is F and H. So that's why you see here A times F plus B times H. So let's take a look at this first example that has some for us. Excuse me. So the first thing we're going to do here is state the dimensions. So this is a 2 by 2 times a 2 by 2. So I check the values in the middle, they match. And so the answer will be a 2 by 2 as well. So this means that there's going to be 4 spots I have to fill. So if I want to fill this first spot, that number is in the first row and the first column of my product matrix. So I go to the first row, and here's the first column. So we're going to take -4 times 6 plus -9 times -5. Then if I want to find, we'll just move right here, this element. Well, this element that's going to be here in the blue box is the first row and the second column. So now I still look at the first row, so it's still -4 and -9, but now it's -1 and 4. So we're going to take -4 times -1 plus -9 times 4. And then moving on, so down here, that's the second row, first column. So I look at 3 and -2 and 6 and -5. So take the product of the first element in each row or column, so 3 times 6. And then add to that the second product, which is -2 and -5. And then we finish by looking at the second row and the second column. So I'm just getting rid of some stuff here so there's less in the way. So second row, second column, and that will give us a 3 times -1 plus -2 times 4. And so then we just perform, the simple arithmetic here that's in each spot. So first up, we would have -24 plus 45, and that's 21, Moving over here to the right, we would have 4 minus 36, which is negative 32. Down here on the bottom left, we'd have 18 plus 10, which is 28. And then negative 3 minus 8, which is negative 11. And so this would be our final answer, or the product of matrix A times B. Our next example is the same process. We just have matrices of different sizes here. So a 2 by 2 times a 2 by 3. Look at the inside numbers. So long as they match, the answer will be the outside dimensions. So this one's going to be a 2 by 3. So it will have 2 rows, but 3 columns. So when I find the first element, so that one right there, that's the first row and the first column. So I multiply 9 times negative 3, which is negative 27, and add to that negative 5 times negative 1, which is just 5. Slide over. This element right here is the first row, but the second column. So I'll take 9 times 13, which is 117. Oops. Sorry, I changed the color on you. 117. And then plus negative 5 times negative 7, which is 35. The next spot, that's still the first row, but this time the third column. So this is 9 times negative 5, which is negative 45, plus negative 5 times 2, which is negative 10. Now we can fill out the bottom row. So I'm going to get rid of some of this highlighting here. So the next one I'm going to find is the second row, first column. So this will be 6 plus negative 4. And then now we'll just we'll slide down and see if we can get by with showing perhaps less work here. So this element right here, second row, second column. So that's negative 2 and 13 plus 4 times negative 7. And then here, second row, third column. So that's negative 2 and negative 5, which is 10, plus 4 times 2, which is 8. And so now my final matrix, or the solution here, is going to be negative 22, 152, negative 55, 2, negative 54, and 18. Oh, and I do see I made a sign error here. So this should have been a positive 10. And then that would be our solution.